All right, guys, last video of the week. Let's do this. So today we are talking about volume. Tomorrow we will also be talking about volume, but you can just rewatch this video if you need a refresher. Specifically, the volume we're going to be talking about is volume of rectangular prisms. Before we specifically get to that, just like how I talked about what area means, I want to refresh you on what volume means. Okay, we know when we're describing area, that's a 2D shape or a two-dimensional shape, which means we need two descriptions to describe it. And when we end up using a formula to multiply those dimensions, we end up with little squares that we count and describe the area of our shape, which is why they're called square units or units squared. Sorry. Well, volume is similar in that since it's a 3D shape, it's a three-dimensional shape, or a three-dimensional object, we need three descriptions to be able to accurately describe the size of something. Think about an Amazon box, okay? And Lord knows I bought a lot of stuff from Amazon when I was laid up for surgery last week. So if we have an Amazon box, very poorly drawn Amazon box, I can't just describe the shape of that box to you by saying, oh, it's, 3 units by 2 units. Because Lord Almighty, that box could be this long. It could be this long. Okay. So to be able to accurately describe the size of our box, we not only need a length and a width, but we also need the height of our prism. Ms. Khan, what is a prism? Okay, I will tell you in a second because I forgot to mention one thing. Just like how we multiply these two dimensions together to get squares, we multiply our 3 dimensions together to get cubes. Okay, and so when we describe the units of our volume, we are going to describe them as cubic units or units cubed. Because to describe a 3-dimensional object, we need something 3D. And that's how we can describe how much space a volume, or how much space a 3D object takes up. That is how we describe volume. So now let's talk about prisms. Think of a slinky, okay? If you just look down at the top of a slinky, you will see a circle, okay? When you stretch that slinky, it's like you're stretching that 2D circle into the 3D world. That's a lot like what prisms are. Prisms involve taking a shape such as a triangle and then extending them out into the 3D world. Now, this is a triangular prism because the triangle is what I'm stretching, but we also have stuff like trapezoidal prisms. Okay, we could have hexagonal prisms, which I'm not going to draw because that sounds like a lot of work. We have rectangular prisms, which you all know as boxes, okay? But all of these are prisms because we're taking a 2D shape and stretching it into the 3D world. Now, sometimes you see these stretched upwards, sometimes you see them stretched outwards, okay? But it's all about taking that 2D shape and stretching it into 3D world. So now how do we use that idea to find the volume? Let me talk to you about the volume formula. The volume formula for all prisms is the same, no matter what shape their base is. So even though this object and this object and this object have different shapes that we're stretching, they still all have the same formula. So the volume of the prisms equals base times height. Now, what you'll notice is that this B is capital. This B is not the same thing as a base we use to describe a 2D shape. This big B represents the area of the shape we're stretching. So the area of the 2D shape. The area of the 2D shape that we're stretching outwards. So the area of the base with a capital B. Right? This H is not the height of our 2D shape. This H is the height of our prism. Okay, or how much we're stretching it. So, if I wanted to find the volume of this prism, I would use this formula. I would find the area of my base, and I know this triangle is my base because that's the shape I stretched into the third dimension. Okay. And so to find the area of that base, it's half of my 2D base times my 2D height. And then all we do is multiply it by the height, or how far we're stretching it. Okay, so this H and this H are different. Okay, now you wouldn't have needed to know these on the STAR test this year, so I wasn't going to go over them, but the reason I showed you this is to let you know that oh my gosh, cannot speak. The volume formula for all prisms is the same. Okay, you find the area of the base and you multiply it by how far you're stretching it. You multiply it by the quote-unquote height of the prism. Now, as you can see on these notes, we are mainly just focused on the volume of rectangular prisms. So what you need to think about is, if it's a rectangular prism, my base is a rectangle. So to find the volume of my rectangular prism, I need to find the area of my base, which, as I mentioned, is the big B in this formula, and I need to multiply it by my height. So, on this example I have right here, I'm calling this my base, and the area of that rectangle up top is 10 squares. Okay, so I multiplied these two to get 10. So the area of this is 10 squares. It is 4 cubes tall, so I'm going to multiply the 10 and the 4, and that's how I get an area of 40 total cubes, or 40 units cubed. Okay? That's all you need to worry about with volume. Okay? Let me know if you have questions. You've almost made it through the week, and I will see you next week with a different topic.